Hello, welcome to Narcolepsy Pumpkin. If you haven't done already, why not click on subscribe, click on the bell, and that way you'll get notifications when I post new videos. So, if you were following closely at the end of the last video, you may have noticed there are actually some commented out unit tests still there. That's because in order to do that bit of transition, I only used a handful of the unit tests to make sure there was no significant change within the code's behaviour. We still have to sort those unit tests out, so they need transitioning in a similar way. But I'm going to try and do that by having a single function within the tests that translates our current expected output to our new expected output.
So the first thing we're going to do is uncomment the bit of code. I'm then going to transition this from being a two-dimensional array into an array of arrays. This brings it closer to what we're expecting as the outcome from the current maze, because that's an IEnumerable of an IEnumerable. The next piece we have to do is start writing a function to translate this into what we're expecting now. Originally, as you can see by the comment, I had this weirdly in my head as a 90-degree clockwise rotation of the numbers, which is a long way from the truth. It's basically a transposition of the x and y coordinates. So position 1, 1 remains position 1, 1. Position 2, 1 would then become position 1, 2. The aim, once writing the bit of code that will translate that, is to refactor that out into a function we can then reuse for the rest of the unit tests. So now we've got it there or thereabouts, it's just a matter of pulling out the debugger and fettling that function until it returns exactly what we're expecting it to. Once we've done that, we'll be able to reuse it for all the other unit tests. Because watching that in real time isn't necessarily going to be particularly useful or riveting, we're going to do a bit of fast forward here. After a little bit of fettling and the realization I hadn't pushed the record button, we've got to a point where these tests actually pass. You can see there's an instant transition at the end of this where all these to array appears. One of the next steps we're going to do is replicate those down to the next function. The reason for that is we need it to resolve these link queries before it returns them, so we're not leaving them as a kind of a lazy thing to resolve at a later date, which could end up causing us a little bit of a headache. So we've completed that for the big test class. We've still got a load of little test classes that we haven't done anything with yet. So these again need the same transition, but it would make sense at this point to pull them into just one test class, because there's no reason for them to be anywhere else. They're all characterization tests. They were just built kind of to test slightly different scenarios. So what I'm going to do is pull them in and then add all the transition bits that we've done to the other tests to them. So again, get rid of the first row because that was never really needed. Change them to an array of arrays, and then make them use the same translation function as the rest of the tests. Again, we're going to do this to a few tests, so we're going to do a bit of a fast forward again. So that should be the lion's share of the test sorted out, and just as a final check, we're just running it to see visually it's still creating a maze as expected. So moving all those tests around has left us with a few empty classes and a few supporting objects that need to be moved. So what I'm going to do is move all our fake objects into a fakes folder within the actual tests class we're actually keeping. Get rid of all the empty classes and all the empty projects, and tidy up some of the naming.
There are a few functions still remaining that are not within our immutable idea, i.e. they're not functional as such. We need to change those so they now return a new state in the same way as we've already done with the rest.
The methods we're going to address are currently a collection of actions that are still sat in a sub-method of the main function. We're going to push these outside in the same way as the others, make them have a state passed in, and make them pass a new version of the state back. This should tidy up the last few bits of this code. This isn't something particularly new. You've seen me do exactly this in the last 2 videos. So, in the interests of you not watching something really painful again, we're just going to speed up until we get to something new and possibly interesting. this next bit looks relatively simple. We've just got a few functions that aren't using the state as passed, they're using the local variable for May state. So pushing that back up into parameters seems relatively sensible. So there we go. Making sure we're actually talking about the same state, the one that's passed it in, everything appears to look reasonable at this point. Only when running the unit tests again does this in fact reveal we've created quite the rabbit hole. Because there are several dependent functions down the road, which are also assumptively looking at the May state as the internal variable, that means they no longer work because the state has not been changed or updated or passed back. Therefore, we're actually looking at the wrong state in this context. So there is a rabbit hole to be followed, and quite a few functions that just need the state passing in explicitly, as opposed to assuming we're using the internal variable. And this would be a stepping stone to getting these pulled out of the function. In hindsight, it might have actually been easier to pull all these functions out into the main class and then resolve the errors, because this would have absolutely highlighted everywhere we were relying on the internal state variable as opposed to a passed in state. But in the interest of making this slightly more painful than it needs to be, I did it this way. And because this is again largely quite tedious, now I've explained what the problem was and how I'm going to resolve it, we can probably speed this up too. So that's this completed. The last bit is just to take all those functions, cut and paste them out into the main class, and then just go through as before and make them all private functions. Again, particularly tedious. Let's get the fast forward on. So that's it, we've actually separated the state and the functions. That last line of comments was the old separation between the main function body and all the subfunctions we had refactored out.
We're into the journey of moving bits of the code around to make it make more sense. The end game really is to end up with things in classes that are going to change for the same reason. So we're just adhering to the single responsibility principle. That means that all the things that act on movement are going to be in one class. All the things that act on the actual maze blocks themselves are in another. This gives us some segregation of responsibility, and it should make the code much more easily readable by anybody in the future.
So the next step we're going to do is pull all the functions that we are using to determine our position, or use to determine our position, so whether we are at the start of a row, end of a row, first row, so on, into their own class. So these are a fairly simple set of functions we can pull out into another class. We're going to make that a static class. We're going to turn all those functions into extension methods, and then go through and resolve the invocation so that all of the calls are being made as extensions, as opposed to using a static method which is referencing the actual class. Once we've sorted out the protection level of the functions, we can make the class static, make all the functions extension methods, convert them all to expression body, and then we can go and use the resharper tool to change all the invocations to extension invocation. So, we've managed to sort out all the tests. We've managed to conclude creating an immutable state. We've also managed to segregate all the functions that act upon the state from the state itself. We've made the code functional by making sure all the methods or functions return a new state rather than a mutated state. We've also taken our first steps into changing this code architecturally, shifting it to use extension methods, and the idea behind that is to split the code into separate classes which collect the functions that are acting for similar reasons together, mostly adhering to the single responsibility principle. The rest of that journey will continue in the next episode, but for now, this is the end of a slightly shorter episode in the amazing Refactor series. Please join me again next time to find out where this ends up.
If you found the content of this video useful, then please click on like, and if you've got time, leave a comment to let me know what you actually thought. Getting feedback is useful because that means I can create more content that's suited to what you want.